So temporal concepts, right? There's a document here. Can you see a document on your
Yeah,
screen?
it's clear as day.
Great,
Yeah.
great. So first of all, what are they for? I'm going to kind of read through it and then explain it if there's questions, really. I think that's probably the easiest thing to do here. So the idea is to enable general inference between semantically unrelated tasks, i.e. that they're temporally related, but they're semantically unrelated. So at the moment, you can only do inference between two tasks that share a common term.
Mm-hmm.
Yeah.
Yep.
So if you actually want to create a sequence of events of arbitrary terms, you're out of luck.
Right.
There's no way of doing that. So the idea, what this does, temporal concepts they're put in place to enable us to do basically temporal induction between arbitrary terms, whilst maintaining the constraints imposed by assumption of insufficient knowledge resources.
Yep.
So essentially how that works is take the occurrence time of two tasks, and you can think of them as being a semantic relationship. It's just that in this case, it's a temporal relationship as opposed to a term-specific relationship.
Yep.
So what we're doing here is really just switching out the common term for an occurrence time. But there is a difference here.
I
It's
see.
not.
I see. So like, if it's like, I don't know, cat furry, but then you want to talk about anything that's furry temporally, you'd just switch out the occurrence time there, and anything that's involved.
No. Forget what the term is. In fact, it's completely irrelevant.
Right.
I'll give you one example of a normal term. Is right. Tim's a cat and cat's an animal. Right. If we could pick both of those because they've got a common term of cat,
Yep.
and we can do inference on them. Tim's an animal.
But you want to swap
But
out cat for
if we had,
time.
well, we're not swapping it because those you could have two events that are coming to the system that don't have a common term.
Okay.
Right. So Tim's a cat. And actually, let me make it something that's more event relevant. Switch one on, light on. No, you can cancel that. No, switch one activated, light one on. Yeah. So there's no common term between those two statements.
Okay. Yep.
Right. So one occurs, another one occurs. There's a sequence of two events, but there's no way of connecting those unless you're using the temporal relationship between them. So that's the idea of a temporal concept. It connects two terms that aren't related by a common term.
Okay.
But the actual occurrence time doesn't have to be exactly the same. Obviously in a term named concept, the common term is exactly the same in both of the terms.
Okay.
Both of the tasks in the concept. With an occurrence time relation, the relation can vary based on the time. So they're related by time, but then it doesn't have to be exactly the same time. So it could be in the past, or it could be at the current moment, or it could be in the future, with varying degrees of resolution of those. So it could be further in the past, further in the future, etc. So they're still related by time, but they're not related by the exact same time, which is different to how a normal relational term would work. Is it's the exact same term.
Right.
Yeah. So this is a slightly more complex understanding of what a term is. It's a fluid temporal relation, but there is still a relationship between the two tasks involved, i.e. they're related by time, although that time can vary. So you can think of it as the interval between the terms, the interval between the tasks is its temporal relation.
Yep.
It can be positive, negative, or it can be zero.
Yep.
i.e. present, past, or future. Okay, now the way we actually go about implementing this, it's actually not that different to what we have now. So the existing system functions pretty much as it does now, except it just creates another kind of concept as well as everything else it does. So a concept is formed for each unique occurrence time associated with a task. So if an event comes into the system, and it would only be events that have occurrence times, an event comes in, it does its normal concept creation process, and at the same time, it creates a concept called the time that happened. So if this is cycle 27, creates a concept called 27.
Yep.
Yeah.
Mm-hmm. I'm with you so far.
And now any other events that come in that are also 27, they also go into the same task, 27. Sorry, the same concept, 27. So it will build up a collection of events for that moment in time. And then the cycle will change and we'll be on to cycle 28. And then another concept gets formed for any new events coming into the system now, and those go into there in the 28. So imagine you've now got a collection of these concepts for a period of time in the system. Within the concept itself, it's a similar structure to a normal concept. It has task links, term links, tables, etc. But there are some differences. So for example, the table entries for truth and desire, unlike in a normal concept where they're storing the same content with different occurrence times, in a temporal concept, they're storing different content with the same occurrence time. Mm-hmm. All right. So there's no need to project them, to project the confidence values, because the times are already projected to the same moment, because that's the moment that the concept represents. You still need to rank them because you still got to select one from them somehow, which we need to decide which way we're going to do that. But it's a simpler model than what we have with the other ones, with the term name concepts.
Just to be clear, a concept isn't created for the exact occurrence time, right? It's created for the time span, that interval.
No, it's created for the exact time.
Okay.
Yeah, it's for the cycle that's currently executing.
Right.
Okay. Yeah, remember that the system clock updates the cycle every, say, 10 milliseconds.
Yeah.
So within that 10 millisecond window, there will be a number of events potentially arrive.
But that's what's called the occurrence time. Okay.
They will go into the occurrence time for that particular cycle.
Okay. Yep.
So in one sense, yes, you're right. It is a duration event, as all events are, because in fact, in this particular case, the system cycle is in fact 10 milliseconds long. Mm-hmm. So that cycle is a window of 10 milliseconds. But that's subjective and relevant and relative to the specific system cycle time. So you shouldn't assume it's 10 milliseconds, because it could be different on different systems. Mm-hmm. It's just a cycle point.
Yeah.
Okay. So then the other aspects of a concept, task links, they're exactly the same as they are now. They have tasks in them, and you use those to select them to do inference. One simplification here is that because the term is naming the concept, but in this case, the occurrence time acts as the term, there are no subterms to worry about. Like if it was called Tim Cat, you'd have to worry about Tim's a cat and Tim and cat as subterms. But in this case, the occurrence time is 27. There are no subterms of 27. So you don't create any subconcepts, and you don't need to propagate the tasks because there are no subtasks, no subconcepts to propagate to. Mm-hmm. So that's the simplification. Term links are where the biggest difference is. If you remember, term links are it's the bag of links that point to semantically related concepts that you pick a belief from to go with a task from the bag you're in.
Yep.
Okay. The difference here is that the links only point to temporal concepts. So they're really just a set of numbers.
Okay.
And they also, they only map to a certain period of time. For example, it may be that we use some function of the duration value. So if we said duration was 80, it might be that the term length span is from minus 40 from the occurrence time of the concept to plus 40 of the occurrence time,
Right.
as an example.
Yep. Yep.
Yeah. So that would mean that concept bag could pick a term link within the duration window. And actually, to be honest, I think what we would do is actually we would make it bigger than that, so that it could pick things outside of the duration as well. So that was probably not the best example. We would probably use a smaller duration than 80, in all honesty. I think at the moment it's 8. So if the current duration is 8, we may use something like 20 as an example. So half of the space falls within what we would call concurrent time, and half of it falls either before or after the concurrent time.
Right.
Yeah.
Mm-hmm.
Get my brain around it. Right. So at this point now, we've got a concept. We've got things in the tables. We can select a task. We can select a term link that points to another temporal concept, which is within a predefined window. At that point, we can then do inference because we've got a task and a belief, exactly as we do normally. But the only rule that would work, because there's no common term here, none of the other rules in the system would work except these two. These are the only two rules that would apply if there's no common term, and that is the temporal induction rules. So the first one is for a sequence event, i.e. something happens before something else, and these are all the possible derivations, or something happens at the same time as something else, i.e. it occurs within the duration window. Therefore it's a concurrent task, and that's it. There are no other temporal induction rules to know. That's it, its entirety.
So these concepts will be quite short-lived because they're not going to be accessed as the cycle times go much further into the future, right?
Correct, which is exactly what it says here.
Right.
Yeah. So jumping to that point, as you mentioned, yeah. So basically, they're short-lived, unless they happen to coincide with a high priority task coming into them from elsewhere, which occasionally will happen because they will be particularly relevant for certain things, but generally they won't be. They will create some small sequences and pass up the hierarchy, and then they will just die out. So they've done their job. They're really only there to start the temporal chaining process off.
Okay, cool.
Yeah. One thing I should mention, it's quite possible that these bags, as well as having this temporal relationship, purely coincidentally may end up also having a semantic relation with some common terms as well, right, which is not an issue. So they would in fact get processed at the same time by general inference as well. Yeah. So it wouldn't exclusively just do these temporal induction rules. It would do any applicable general inference rules.
Mm-hmm, mm-hmm. Yeah, I understand. Yeah.
Okay, so there's a few discussion points here, basically. So the key thing is, as I said a couple of times, is to generalize temporal chaining so that we can build sequences of arbitrary terms. Mm-hmm. Without this mechanism, we can't do it. In 1.7.0, they had this horrible process where they would every input they would store the previous one and they would link it to the next one, and create a sequence of those two with a priority based on the confidence values and the time between them.
Right.
Which it's a real hack.
Yeah, it kind of breaks out of the general idea of how the system works.
Yeah, there's no unified principle going on there. It's definitely a hack, complete hack, mm-hmm, but it's also extremely mm-hmm limited.
Right.
In the sense that the only sequence it could do is this thing plus the thing before it, and it can maybe combine elements of those further up the line into other things, but that was it. If it wanted to link the first thing and the fifth thing as a sequence, you're out of luck. That wasn't going to happen. Whereas with temporal concepts, based on the priority of items, they can link anything within the window of operation, forwards, backwards, concurrently, however you want to do it. So it's much more flexible and much more general.
Right. Are you going to do a paper on this for AGI 16?
I've left it too late.
Ah,
Deadline's in 2 days. I thought
you
about that, and
can
I
do
thought,
it. No.
yeah, I thought maybe I could do that, and I thought, oh, there just isn't enough time.
Yeah.
I haven't done enough work yet to be able to say that. But there's there's other conferences, so it's not an issue.
Yeah.
So the couple of issues to think about. One is how do you stop it creating millions and millions of possible permutations? Well, the key thing here is it's constrained by two things. The window operation wrapped around the concepts is of a fixed window size. So once things fall out of that window, they rapidly die.
Mm-hmm.
Actually, I think that's the main constraining factor, to be honest. Yeah. The other thing, it's only really focused on the front end of the system. So what we're aiming to do here, we're only trying to create sequences from tasks coming into the system, typically.
Mm-hmm.
So it's more about perception than anything else, or linking percepts with other actions that the system's generating.
Right.
So it's to form higher compound structures of percepts. So that's the goal here. Once you've moved beyond that point, the normal inference system can take over and use common terms to build more complex structures after that. But at the initial stage, it needs this helping point. What's this one about? Oh yeah, so this was where I was able to get rid of the cross-modal integrator. Do you remember we had that where it would form compound terms from the three channels A, B, and C?
Yeah, I do remember that.
Well,
yeah.
I've removed that because, in fact, we can do that with the temporal concepts now. Because if a concept has its own time as part of its term link window, it can select itself as a potential term link, so it can get it belief from itself.
Yeah, absolutely.
So it can now form concurrent with itself directly, so it doesn't miss out on itself. So that can do the same thing as the cross-modal integrator did directly without having to have that. So that's a nice little benefit.
Yeah.
And then we spoke about the last point. Now, I know that was kind of jumbled.
That's mostly my fault for interrupting you, but no,
that's fine. That's okay.
I got the general.
Any questions? Because the key thing.
What's not clear to me is, say you have two arbitrary statements that have a similar occurrence time. How? Like, I was wondering if you could run through, say, in the context of the actor model, how these two statements would flow through to the task creator into the concepts, and then create those concepts, and then I have a little bit of difficulty understanding the term link between that particular statement and the general occurrence time concept.
Okay, let's just walk through it though, because the models change anyway a little bit, so it won't be a bad thing to put this on the screen. So, in fact, you don't ever have to think about two tasks. You only ever have to deal with one at a time.
Okay.
I know we were talking about two tasks. Sorry, my phone's going.
Feel free to answer it.
No, it's done. It's okay.
Okay.
Right, so you only ever have to deal with one at a time. So let's say we have an event that occurs in one of the input channels. It's a sentence now as opposed to a task. It goes into the task creator where it gets converted to a task. Mm-hmm. And what that essentially means, it adds an ID and a time. Mm-hmm. That goes through the task dispatcher. Now, let's assume it's the first task in the system. There is no matching concept, so it sends a create concept message. The other phone's going now. Just one second, Jared.
Yeah, no
I'm
problem.
gonna have to answer it.
Yeah,
I'm back. Sorry about that.
all good.
Yeah. It was my wife. I knew it was. She just told me she's coming home.
Cool.
Not a big issue. Right. So where was? Oh, so yeah. So get the concept creator.
Mm-hmm.
Let's say the event that came in was switch one on. So what it does, it creates the concept for switch one on and the subconcept switch one and the subconcept on. It adds switch one event to its task list. It propagates that to the subterms, the subconcepts. Then that's that normal concept created. But it also creates another concept because there aren't any other concepts in the system at this point. It creates the temporal concept for the current cycle time, which is cycle one.
Mm-hmm.
So cycle one concept, temporal concept, is created, and then it does the same thing with that. It puts the switch one on into that concept. It stores it in the belief table, puts it into its task table, and then it adds a term link to itself because that's the only current relevant temporal concept available.
Mm-hmm.
None of the other time slots at this point exist, so it can't link to any of those. So we've now got a temporal concept and three normal concepts in the system, two of which are subconcepts for the main term named concept.
Mm-hmm.
Following that so far?
Yep.
Okay. So then let's say we then have another event occur in the next cycle, which is horn sounds.
Mm-hmm.
Comes into task dispatcher, and there isn't a horn sounds concept. Goes to concept created, so it creates the term name concepts and the subconcepts in the same way. We're now in cycle two, so it now creates another temporal concept, concept two.
Mm-hmm.
It adds the event to its task links, to its truth table, and its term links. It now adds itself, but it now adds the previous cycle, which is one because it's still within the time window.
Mm-hmm.
So we've got two possibilities for that one. So the first one can link to itself, but the second one can link to itself or the first one. So we've now got those concepts in memory. So when we're now going to select concepts for inference, they're selected exactly the same way. So when tasks went into those concepts, their activation levels were increased based on the task priorities. For argument's sake, let's assume those tasks were sufficient to raise their activation levels to be active. They go to the active concept collator. It selects a number of them based on the selection criteria. In this case, it could select all of them because there's only 3, 6, 8. There's only 8 concepts to select. Selects all of them. It sends an inference request message to them, and there's absolutely no difference in how this works. At this point, they all receive the same messages. So they receive the inference request message. So they select a task, and then they select a term link. And whether it's an occurrence time or whether it's a term link, it doesn't make any difference. It just points to another concept. They go to that concept, they get the belief from that concept, and it's either a normal belief or it's an occurrence time belief. It doesn't make any difference. It's exactly the same process. Mm-hmm. That task and belief is then sent to inference. If it's a normal semantically rated task belief, they just do general inference. If it's a temporally related pair of task beliefs, it will only do the temporal induction rules, unless by coincidence it also happens to be semantically related as well, which can happen sometimes. Mm-hmm. Those results get sent back to task creator, and they get processed exactly the same as any other one.
Okay.
There is nothing any more complicated than that. The only slightly fuzzy bit is managing the duration of the term links so that this initial period is slightly strange because there isn't a full width of window. But once the system's been running 50 cycles, for example, then you've got a sliding window that can move within that. So you can have a full range of term links, plus or minus either side of the occurrence time of the task of the actual concept itself. Mm-hmm. So if the occurrence time is 30 and you're using a window that's 10 either side of that, for example, you can then have the full size of that fitting within the in the term lengths. But until you get up to a certain size, you're only going to have a partial term link set.
Okay, that sounds pretty interesting. So what I guess most of the discussion we need to do is around that sliding window, or is there something else that Patrick wants to discuss in more detail?
No, I don't think so. He hasn't put as much time thinking into the temporal concepts as me, so I think he's just slightly woolier about some of the ideas. Mm-hmm. I'm kind of a bit further ahead in the thinking with them than he is on that particular aspect. But I think he just needs to sort of get it straight in his head. I don't think there are any big issues here at all. I'm sure there are not any big issues. There's some fine detail we need to agree on, and those are the sort of things that Patrick will be good at because he's actually implemented this similar stuff in 1.7, so I think that would be useful. The other thing, just to mention for completeness here, is we've got rid of the anticipated events, or I said we have. I got rid of them. If you remember, in fact, this box used to be the anticipated event box.
Yes. Yeah.
We can do that inside of a concept now. I thought about this. We don't need to process these externally to a concept. So a concept, in fact, I started to draw this out. I think that must be that one. Yeah, so concept state has now got a couple of these extra boxes. So it's got the questions box we spoke about before when we were processing local inference. So there's the question store, but also it's going to have its own anticipated events buffer as well within the concept data space, which is only for that specific concept. And the way this will work, is that? Oh, no, that's the one. So when an anticipated event is sent out by the concept, it will, instead of sending the event to the operator execution, it basically just sends a message to itself, which is like the negative task message that it will get if that anticipated event isn't confirmed. So it basically just sticks that in the anticipated event buffer and says, in the event that I don't receive the anticipated event within a specified time, then this is the message you need to give me to say it didn't come. That's basically it. Nothing any more complex than that. It's not actually a timed message as such. What will happen is when it receives a message in the future, it will check the anticipated event buffer and to see if there are any outstanding messages. If there are messages that should have been confirmed by now but haven't been, it will post that message to itself as the first thing it does, i.e. the negative task message.
Yeah.
Then it'll process the message it just received. That way we don't have to use any timers or anything to have it check in itself.
Yeah.
It basically just does it in the future on the basis that exactly. Yeah. Well, next time it receives a task.
Yeah.
Local inference. Yeah. If it never receives one, then it doesn't really matter because it's going to die at some point.
Yeah. It sounds a lot clearer. I probably have to think about it a little more. But I like where that's going.
I don't know why we didn't think it. I think I was probably influenced by the previous design to a large degree around that particular space. But I'm glad we moved that because I hated that being sat up there. It was just kind of this one thing that I couldn't figure out how to get rid of.
Yeah,
Anticipated events. But it's
sticking out
gone
like
now, which is
a
great.
nail. Yeah,
Yeah, yeah.
cool.
So I'm much happy with this. This is much cleaner, much simpler. And the thing that Patrick identified yesterday, which probably doesn't mean quite so much to you yet, I can tell you it was huge.
Oh,
This symmetry between goal and belief handling.
yeah.
It fills a big hole in the system's ability to do the right thing at the right time.
Okay, I didn't appreciate it at the time.
Yeah, not many people in the world would. Maybe 3. Yeah. So no, that's a big discovery, and very useful. So I'm really excited to see what this can do now. I think we're kind of there at a high level design. I don't think we need to do anything else now. We really are talking about implementation of functions within each of these boxes.
Cool. It's pretty exciting.
Yeah.
I don't have any follow-on questions at the moment, but
Okay.
yeah, thank you for taking the time to explain that to me. I definitely see the temporal concepts as being a much cleaner and more concise way of doing what we were trying to do instead of joining those channels together. I didn't really appreciate that. But this is much cleaner.
That was just one piece of it, to be honest.
Yeah.
And that wasn't bad. It's definitely it's better than what they had before. But this is much better. This is general temporal induction, which is what we've always needed, and it's there now.
Cool. Yeah, like obviously, like we'll probably have a very similar, hopefully a team viewer session again on this with. But yeah, it's really exciting.
Yeah, Patrick's going to go through this stuff with me tomorrow evening. Mm-hmm. We haven't agreed a time explicitly yet, but I'm sure we can find a spot. It will be very similar to the discussion we've just had, except he'll be chipping in his bits. So it's up to you whether you want to join again.
Yeah, I'll definitely join. I'm sure Patrick's got a whole bunch of ideas